So it can't be bad for us to go through this one. I think it's good to try to go through the one that is the closest to what you're going to be taking. It isn't
Right.
always what you get. In other words, if you go buy a Kaplan book, or say even worse, you logged on to the Kaplan site online, and they gave you 3 questions. They're going to give you the 3 toughest questions they can possibly find. Why? Because they want you to buy their course.
Right.
So they want to make sure that they're giving you practice questions that you don't have, that you're not going to get.
Right.
And then you'll be convinced to go and sign up for their course. So it's not a good idea to go to any of these private publishers and look at their practice tests. But this one, they don't have any ulterior motive as far as I can tell. In other words, this is put out by the College Board. I don't believe they sell a package where, you know, they help you with the test. Maybe they do. I don't know. I might be being naive in that. But even still, I haven't noticed any super difficulty. This thing seems to match exactly what you're going to see. 20 questions for 25 minutes, no calculator on this section.
Okay.
And every math part to the SAT will give you these 10 or 11 figures. You should know most of these anyway. And in fact, it's worth you reviewing these just to make sure you know them. You are familiar with them. You know, they're
I think I'm
area of a rectangle, area and circumference of a circle, area of a triangle, Pythagorean Theorem, the 2 basic special triangles and their dimensions, and then the solids. But they do give you these. If you don't have the solids memorized, you'll get away with it because they'll give you the formula at the beginning of the test.
Right.
All right. Let's go through some of these. Have you taken a full practice test and scored yourself yet?
I actually haven't, but I've taken the ACT, if that's any consolation.
Yeah, it actually is. They are not that different. In fact,
I got a 26 on the ACT. I can check for you what I got in math specifically.
yeah, that's the only one I'm going to have any control over is the math part.
Right.
And I'm not sure how much control I'm going to have on that, but in terms of whether or not you're able to improve it with my tutoring, it would be worth knowing what your base level score is.
Right.
That being the case, let's just go through these as quickly as we can. Like the ACT test, the early questions are easier than the middle questions, which are more medium, and the harder questions are toward the end.
Right.
Now, let's talk about strategy just a little bit.
Okay.
The biggest mistake you can make on the SAT test is to leave a question unanswered. Do not let yourself run out of time before you've seen every question. Because if you do, you won't have time to guess on the ones that you're not going to get to.
Okay.
So the ACT has 60 questions in 60 minutes. The ACT, not the SAT. I'm just going to use it for an example. Stay on pace, and in fact, stay ahead of pace. If 35 minutes have gone by and you're only on question 30, you're way behind pace. Not only are you not going to get to all 60 questions, but you're not even going to get to see them. You want to be more like on question 35 at the 30-minute mark.
Okay, that makes sense.
Yeah, and that way you will have at least seen all 60 questions before time runs out.
And you will have at least given an educated guess.
Right, there's that, but I recommend a pattern where if you're pretty sure you can answer the question, like number 1, is pretty straightforward, then go ahead and spend the time and answer it. If you spend 2 minutes on it and you're not getting any closer to the answer, then put a check mark by it.
Right.
If you look at a question and you know, if you find a question you absolutely know that no matter how much time you spend on it, you're not going to have a clue, then go ahead and guess on it early. And that way you don't have to save it until you are done and then you have to go back and guess something. And
I got a 22 on mathematics, by the way.
How much on your math?
22.
Okay. All right. So I think I can help you a lot, actually. There are also 3 methods to solve every problem. There's algebraic method, which would be the one that you would traditionally think, you know, if it wasn't multiple choice, you'd have to use the algebraic method. There is the back solve method, or what you might call guess and check. That is an extremely valuable method. When we get to a problem where it is better solved by back solving than algebraic, I'll point it out.
Okay.
You remember your goal here. Your goal is not to convince anybody how much math you know. Your goal is to get the highest possible score. That's it. It doesn't matter how you do it. So even if you don't know how to do it algebraically, if you can back solve it and get the answer, that's just as good. There's no advantage in solving these algebraically. And in fact, some of them are going to make it much tougher because you have to formulate the algebra and then you have to solve it. Whereas back solving, sometimes you can solve it in half the time.
Right.
There's a third method where if you have multiple variables in the question and each of the 4 possible answers has those same variables, that lends itself to picking numbers, whatever numbers you want for those variables, and then back solving it. And when we get to one of those, I'll show you. Actually, number 3 is like that. But let's start with 1 and 2. But keep that in mind, that the very first decision you have to make when you're taking this test is which method to use for solving it. Well,
that makes sense.
Number 1 is clearly algebraic.
Right, because it's simple.
Yeah, well, I wouldn't even know how to, I could try to back solve it, but in order to back solve it, I would have to solve the equation. So I'm really algebraically solving it. So what is it?
The answer is wait a second.
Now feel free to scratch paper in front of you and a pencil.
Yeah, I tried to do it in my head.
Well, while you're doing it, let me pull up my writing pad here so that I can...
It's 10.
Okay, good. Number 2. They're not going to have very many questions on imaginary numbers, but they might have 1 or 2 even. You know how to...
So number 2. For I equals the square root of -1, what is the sum of 7 plus 3 times the square root of -1?
You don't even have to know that. You don't really have to know that I is equal to the square root of -1. The secret here is to add like parts. In the same way, in the same way that if I said to you, I've got 3x plus y, and I'm adding that to 5x minus 2y, well, I'm going to add the x's together, and I'm going to add the y's together. And there's my answer. So there's nothing magical about this imaginary number. You don't even need this part of it here. That's, if anything, that's just kind of meant to confuse you a little bit.
Right.
Fact is, add the real parts and then add the imaginary parts, so I get -1 for the real parts, and I get 12i plus 12i for the imaginary part.
Right. So there.
Yeah, okay. Hold on a moment. Let me figure out. Oh, now I see. Whoops. Number 3.
On Saturday afternoon, on M text messages.
I'm going to suggest one other thing, Max.
Yes.
That's that you do not read it out loud. And the reason is that when you take the test, you're not going to be reading it out loud. You're going to have a room full of people. You're not going to want to be reading it out loud. So let's have you do these tutoring sessions exactly as you're going to do it when you take the test. Have a calculator available, but don't use it on this section.
Okay.
Because we will get to a calculator section where you'll want to use it then.
What?
So go ahead and read it and see if you know what the answer is just based on reading it.
It's C.
Correct. Okay. Now, this one is easy to figure out, okay?
Right.
But sometimes, and the reason it's easy is because you have 2 multiplications and you have addition, and it's easy to see that when you read the question.
Right.
Sometimes they'll give you something that has 2 multiplications and a division. And then it's really easy to get confused and difficult to figure out what it is in your head, especially if they have like 4 variables and 2 of them are being multiplied and 2 of them are in the denominator. That's not easy to figure out. It's just real easy to get confused. So let me use this problem as an illustration how you use the pick numbers and back solve method. Notice, first of all, that I got 2 variables in the question, M and P, and neither one of them have numbers attached. Well, that's my first clue that I can pick anything I want for M and P. And secondly, all my answers have M and P in it. So pick a relatively small number for M.
2.
Pick a relatively small different number for P.
4.
Now, from those 2 numbers, how many text messages did Armand send?
10.
How many did Tyrone send?
16.
They total 26. What we have to do is check each of these 4 answers using M equals 2 and P equals 4 until we find this number. Well, notice A, we have 9 times 8, that's 72. B is even bigger than 72. But C, when we put 2 in for M, we get 10 plus 16, 26. And we don't get 26 with anything else. So even if you did not have a clue as to how to do this problem, by picking numbers, it allows you to see how to do it.
Right. It just simplifies it.
Yeah. I'm not sure. It's
like a shortcut.
Easier to explain when we get one that has 3 variables where you have both multiplication and division taking place. Those are very hard for me, and for me I have found that when I run into one like that, I'm going to pick numbers and
take advantage of the fact that it's multiple choice.
Yes, only because it's multiple choice. Same reason that you can get away with back solving some of these. There's a difference between pure back solving and picking numbers and then back solving. They're 2 different techniques. All right, how about number 4?
Copy.
And another piece of advice, always look at the answers before you tackle the problem.
Right.
because it's going
Because it could be simpler than you think.
give you an idea of what kind of things they might be looking for. So what do you...
So 108 is, she starts the week with 108 phone civics.
Good.
Wow, that one was really simple.
Hold on a moment. Let me back up and get on number 5. What's the secret of doing number 5?
Adding like terms?
Well, first of all, we got to get rid of parentheses.
So foiling.
We're not foiling.
Oh, no, you don't need to foil. No, you don't need to.
No, we're just subtracting. But
Okay.
this negative sign here, the
Yeah, you have to
subtraction,
distribute it.
that has to be distributed to every term inside the right parentheses. I don't need the left parentheses. I never did. They were only in there for clarification. But the right parentheses are absolutely required here, otherwise I have a different problem. So what I do is the same thing I tell people how to subtract anything. Turn it into an addition problem. Change that subtraction sign to a plus, and then change every term that is inside there.
Yes.
So now combine all of the x squared y's. How many do we have?
Left, 0.
Okay, we got 1 x squared y there. This one's going to turn into a plus.
Oh, I didn't see that. Okay, I didn't see that. So now you have 2 extra ways.
So right off the get-go, you know the answer has to be C or D. If you were out of time in 10 seconds, that's a 50-50 guess. Okay? Well,
Right.
sometimes that happens, where you've started the problem and you run out of time, but you've immediately eliminated 2 of the answers by attempting the first part of the problem. How many x, y squareds do we have?
You have 2 left, so 2xy squared.
That tells us our answer. We don't even need to do the y squareds.
Nope.
And you'll see a lot of problems like that, where you don't have to complete the problem. If this was not multiple choice, you would have to complete the problem. But the fact that it's multiple choice, you've immediately solved it when you get your first 2 parts of your answer. And that's important. You don't want to waste time where it's not needed.
Oh, shit.
Number 6. What do we...
So I have to plug in an age.
Okay. Well,
I
how
have
do
to
you
plug.
begin this problem?
Well, I'm going to write out the formula, and then I guess I have to plug in an age based on the model.
So how about we try between 2 and 3?
2 and 3, right.
Okay. So what's his height at age 2? What is h of 2?
H of 2 is 3 times 2 plus 28.6.
Okay. What is h of 3?
H equal, so that's 9 plus 28.6.
Okay, so that change from year to year is 3 inches.
3.
Let's just guarantee it. We figured to be 3 because the slope of that equation was 3. But just to be safe, you wanted to definitely plug in 2 ages. Well, let's just check when he's 4. When he's 4, this thing goes to 12 plus the same 28.6. So it's real clear we're going up 3 inches per year.
Okay.
In fact, I'm not even sure you have to do this one. There's no way it could be a number different than 3.
Because it shows that it's the same formula for every year.
Exactly. Well, the question wouldn't have an answer if it wasn't.
Right. Unless it had multiple answers for
What's
something.
the increase in each year between 2 and 5 means it has to be the same. It's not going to increase 3 inches between 2 and 3 and then 5 inches between 3 and 4. Otherwise, the question would make no sense whatsoever. So we really only have to plug in 2 ages and figure out the increase. That has to be the answer. This next one is an interesting problem. First of all, tell me if it's hard or easy.
Well, it looks hard. I don't know if it is yet.
And that is the perfect flag to tell you that it's not.
Because it looks hard?
Yep. If it really looks hard, that means it's definitely not hard. I know that sounds strange, but
it makes sense.
Notice what happens here. Well, first of all, for us to multiply these out would be ridiculous.
Yeah.
That's like 10, 15 minutes of algebra. No way do we have to multiply anything together here. Okay? Let me ask you a question. If I said to you, m is equal to 3/5 p, how would you solve for p?
Divide by 3/5.
Which is the same as multiplying by its reciprocal. And I really prefer to think about multiplying by the reciprocal, 5/3. Because that 5 is going to cancel with that 5, that 3 is going to cancel with that 3. But if I multiply the right side by 5/3, I have to multiply the left side by 5/3. So what I'm really doing is multiplying by the reciprocal. Well, notice this problem is no different, except instead of a 3 and a 5, it's got these ridiculously complex fractions. But they all are multiplying p. So p has to be what?
P has to be p times the reciprocals.
Yeah, it has to be m times the reciprocal of this. Well, which answer is the reciprocal of this?
B.
Yes. We didn't have to...
That's it?
Yeah, that's it. We didn't have to do any math at all. We just had to recognize how to be able to solve this problem right here. And then realize that that's what we're looking at. We're looking at m equals something times p. So to solve for p, I'm going to multiply both sides of the equation by the reciprocal of this fraction. And that is b. And this is another case where looking at the answers really gives you a big clue. In other words, if we were actually supposed to try to distribute this, in other words, multiply r over 1200 times 1, and then multiply r over 12, our answers wouldn't look like this.
Right.
So the fact that we have an answer where no multiplication has been done at all, it's worth looking at. We do have a couple of answers, C and D, where it looks like, okay, maybe they did the multiplication and they simplified. But also know that once you find an answer, there's no way another answer is correct. So once you've found the answer, you're done with the problem. Don't even worry as to whether this is also correct or this is correct. It's not going to be.
Right.
Still no calculator. Now see, so far I haven't noticed any difference whatsoever between the old SAT test and the new one. And part of that is that the old one, you could use a calculator, but it didn't really help you that much. And that's the truth.
Right.
It really didn't. A lot of problems on the old SAT test, you actually could go astray by trying to solve them on your calculator.
Right. Yeah, they try and trick you. Wait, give me one second.
Okay. couple ways to do number 8. They tell you what a over b is equal to, and they ask you what 4b over a is equal to. How would we
Okay.
How would we do this? Let's say it was
Well, if a over b is equal to 2, then automatically b over a is equal to the reciprocal.
Great. That's the easiest way to do it. B over a is equal to what?
1/2.
Now what's 4b over a equal to?
2.
That's it. That's the easiest, fastest way to solve it. The other way would be to solve for a, so a equals 2b, and then substitute. So now we have 4b over 2b. The b's cancel, and I still get 2, but it's a little extra hard doing it this way. So the way you did it was by far the best way, quickest. Systems of equations. You're going to have at least one, maybe 2 questions regarding systems of equations. Always solve a system of equations from your algebra days.
You have to get one of them in the term. Like you have to either get y in the terms of x or x in the terms of y.
Or you could use elimination. Notice that these are very, very close to being in standard format. Is all I have to do to change the second one to standard format is to list the x term first, and then 2y, and that's equal to minus 19. Now, this is equation 1, this is equation 2. You could do it the way you suggested, which is to solve one of the equations for one variable and then substitute into the other equation and solve it. But I don't think that's the easiest way to do it. To me, elimination has always been far easier. And elimination is where we're going to either add or subtract these 2 equations from one another, and one of the variables is going to get eliminated. That's why it's called elimination. Well, if I add these 2 equations right now, I don't eliminate anything. If I subtract them, I don't eliminate anything. But what can I do to equation 2? To make
Multiply it by 2.
How about we multiply it by 3? And I'll show you only one reason why I'm going to do by 3 instead of by 2.
Oh, because it's negative.
And then I'm going to be able to add the 2 equations. Now if I'm going to multiply it by 3, I got to do both sides. So my new equation 2 is now this one. It's exactly the same as my old equation 2, only I've multiplied left and right side by the number 3. And the reason I did 3 is because everybody is more accurate when they're adding rather than subtracting. Okay, I'm now in a position where I can add these 2 equations and the x variable goes away. What do I get?
You get 10y equals negative 80.
So y equals
negative 8.
Do we need to solve for x?
No, you can plug x in.
Hold on.
Plug y in to get x.
Look at the question. We're supposed to solve for x. But we just solved for y, and what are we looking at in the answers?
Well, there's only one with a negative 8, so it's b.
That's got to be it. We don't need to waste the time to solve for x. Okay?
Right.
Now, let me just go back, not be done quite with this. I'm going to do what you suggested, which is just as valid, which is to multiply equation 2 by 2. That gives me minus 2x plus 4y equals minus 38. Well, now I can still eliminate a variable, but it's going to have to be y. And I'm only going to eliminate it by subtracting the 2 equations. Subtract those 2 equations, what do you get?
You get 5x equals 61.
That's why subtraction is harder.
61.
That's why subtraction is harder than addition. You made a mistake when you subtracted negative 38 from negative 23. Here's what negative 23 minus a negative 38 means. It's actually plus 38. That's 15. And I'm subtracting the bottom one from the top one. So now I know what x is. X is 3. So I got an answer, and there's only one x that's 3, and it's the B answer also. So they really give you a break here in that if you can solve for either variable, you have the answer immediately. You don't have to take the time to solve for the other one. But notice what happened. When I set the problem up to subtract the equations, it was easier to make a mistake than when I'm adding equations. And that's why, to begin with, I decided to multiply by 3, because then I'm going to be able to add that to that, and x will go away, and you saw what happened.
Right.
All right. So I got to be careful here. I do have another session, so I'm going to have to go at 6:30. So here we have g of x equals ax squared plus 24, and g of 4, they're telling us, is equal to 8. Well, let me give you another problem just to clarify something. What is f of 3?
4?
Yeah, in other words, if there's something in the parentheses other than x, whatever it is, you substitute it for x. That's the way these work. Okay?
Right.
No matter how complicated. In other words, I could have said, what is x squared over x plus 1? And say, what's f of that? Well, I'm going to take this entire expression and substitute it wherever I see x. That's the answer. So no matter how complicated it is, that's what you do. Now let's go back to our problem. So if g of 4 equals 8, how much of g of 4 can I figure out by plugging 4 in?
If g of 4 equals 8.
Mm-hmm.
Well then,
if I just, let's start with this. What is g of 4?
8.
Well, I mean, if you only knew this formula, and I said to you, what is g of 4? Okay.
A times 16
plus 20.
Plus 24.
Okay, so that's what g of 4 is, and they're telling us that that's equal to 8.
Right.
Solve that for a.
Okay. So 16a equals negative 16 divided by 16, a is equal to negative 1.
Okay. Which means that our true g of x is negative 1 for a times x squared plus 24. That's what our function actually is. And now what it wants to know is, what is g of negative 4?
Okay, so then you plug in negative 4. So negative 4 squared.
What is that? And let me write it the way you said it. And it's important to do it this way.
Right. That makes it negative 16.
Okay. Negative 16 plus 24 is equal to 8. That's what g of minus 4 is equal to, 8. So this was just, yes, this was just a two-step problem. In other words, the first step was to solve for A. And once we had A solved for, now we can figure out what g of minus 4 is.
Right.
Okay, let's go find 11. I think it must be up. Yeah, here we go. And we're not in a calculator section now. Still no calculator right there.
Okay, so 11.
So how are we going to solve this one? What are they asking conceptually?
Sorry, excuse me.
Yeah, what are they actually asking?
Well, it's that B equation equal to the C equation.
Ah, that's it, exactly. So what am I going to write in order to solve for x?
You're going to write 2.35 plus 0.25x equals 1.75 plus 0.44 x.
Just 0.4x, yeah.
Yeah.
And now I have one equation and only one unknown. So I'm going to be able to solve it for sure. Okay? How do I solve it? Let's just go through your algebra.
Subtract 1.75 from 2.35.
Okay, that gives me 0.6 on the left side.
0.6. Then you add on the right side. So I'm going to subtract negative 0.25 from the right. I mean from the left.
No, from the right. In other words, you want numbers on one side, variables on the other, always.
Right.
And there's nothing magical about having the variable on the left. In fact, you'd rather put it on the right if it results in a positive coefficient instead of a negative coefficient.
Yeah, that's what I said. Subtract from the left so that it goes to the right.
Okay, I'm sorry. Yeah, I misunderstood what you were saying. So what goes on the right over here?
So you're going to have 0.25x.
No, I got 0.4x minus 0.25x. What is that? I can combine those.
Oh, it's
Maybe that's why they put the 0 in there. Ah, they were trying to help you out a little bit. Notice if I put a 0, it actually does make it a little bit easier.
It's 0.15x.
Yeah, exactly. Now what?
Divide by 0.1. Divide 0.6 by 0.15.
What do you get? No calculator. No calculator.
I think it's 0.3, but...
Well, let's talk about this for a second. Since, in other words, in the past, this would never have been important for you to be able to do, because you're always going to use a calculator.
Right.
But...
Oh, it's 3.
Almost.
It's not 3?
First of all, the numerator is bigger than the denominator, right? So the answer has to be greater than 1.
Right.
If your numerator is smaller than the denominator, the answer is going to be...
Oh, it's 4. It's 4.
4, yeah.
I don't know why I kept saying 3.
And then always on a problem like this where you haven't been able to use the calculator, always check and make sure that 4 times 0.15 is 0.6. Well, I shouldn't say always. Take that back. Now, when you're taking the SAT test, time is such a factor that it can be dangerous spending too much time checking your answer. I mean, you could really check the answer the hard way. Take that 4 and go up and plug it into both equations and make sure that B is equal to C. That would definitely check, but that would take an extra minute probably to do. So you don't want to do that. As long as you're confident that that is 4. And that's only 4 because 4 times 0.15 is 0.6.
Right.
It is a little interesting they put that 0 in there. I don't like putting that 0 in there. But it actually helps to do the problem, because otherwise I've got this as my problem. And that is not as clear that that's 0.15x. It still is 0.15x, but it's not as easy to see.
Right.
Number
So wait.
I'm sorry, what?
I thought I had the answer.
No, we did. It was 4. Oh.
No, it's price per pound of beef.
Ah, so we have to plug 4 into the first equation.
Oh, wait. Okay, so it's 335, which is D.
Yes. In other words, no, I'm glad you saw that, because I didn't see it. I immediately assumed they were asking us to solve for x, and they weren't. We had to solve for x in order to answer the problem, but it was a two-step problem. You got to solve for x, and then you got to plug it into the right equation to figure out what, well, C is going to be the same price, right? In other words, the price of chicken is also going to be $3.35.
Right.
Because we set them equal to one another, they have to be equal. So we just have to solve for one of these to answer the question. If they wanted to really be sick, they would have put 4 on there as an answer. Right?
Right.
I mean, if they really wanted to mess with you, and they're trying to get people to make mistakes, they would have put 4 on there, but they didn't. And there's a reason for that. They want to give you a second chance. If you made the mistake that I made to come up with 4, and now it's not on there, I must have done something wrong. I got to go back and rethink the problem. But if they had 4 on there, I would have just blindly checked it and gone on to the next problem. Right. So they do frequently give you a break like that, where you have a chance to catch your error. They don't always, but most of the time I would say they do. If the line xy passes through the origin and it has a slope of 1/7, is that a slope of 1/7?
Yeah.
No.
No.
No. Slope, first of all, that's a slope of 1.
Rise over 1.
It's got to be flatter than that.
Very shallow.
Yeah, very, very flat. There's a slope of 1/7. Okay?
Okay. Which of the following points lies on the line? It's not 1/7.
Certainly not the first one.
I think it's D.
Yes, it is. In other words, the x-coordinate has to be 7 times the y-coordinate. And you can see that. If I go out to 7, that's got to be 1. If I go out to 14, I'm going to go up 1 and to the right 7, so that point's got to be 2.
Plus 14.
14
2 is a very shallow point.
Yeah. What's the equation of this line?
Y equals 1/7 plus.
No, x. There's always, in other words, you're always trying to put it in y equal mx plus b format.
X plus.
That's
like
it.
A decimal.
No, it goes the y-intercept is 0.
Oh, you're right. Because
so plus 0 if you like, but you certainly don't write that in. So this is the equation of the line. And then, basically, another way to answer this, if we can come up with this equation, we can just plug in points and see if it works. Well, the first one clearly doesn't work, and it's only when you get to D where 2 is equal to 1/7 of 14. But again, this was a case where you were actually able to come up with the proper answer without knowing the equation of the line, and that's fine. Like I said, there's no math teacher judging your work and studying your notes. The whole goal is to get the answer and nothing but that. All right. That's probably a good place to stop.
Okay.
Well, no, we got time for one more. I just realized that the next page is merely scrolling down. So let's do one more. It's not quite 6:30. Still no calculator. A goodly portion of this test. Oh, it must be all 20 questions are no calculator.
All 20 questions are no calculator, then they give you a break, and then there's a different section of the test which is calculated.
Yeah. But I'm going to guess that the one that you can use the calculator on is not that much different.
No.
And don't assume that, wow, you're going to have to use the calculator on every question. I'll bet you if there's 20 questions on the calculator portion, you only need the calculator on maybe 2 or 3 of them. That's what I'm guessing. And I haven't looked at them yet. But that's the way they set it up. They're not looking to see who's great with their calculator. You know what I mean?
Right.
All right. So, which of the following, on number 13, is the equivalent of that fraction right there? How do we solve it? Let's write it down. What's the very first step I want to do to attempt to simplify this?
Add them?
Yeah, add the denominators. In other words, in order to simplify it, I want to turn the denominator into a single rational quotient.
Right.
So I add 1 over x plus 2 to 1 over x plus 3.
Which is 3x plus 6 plus 2x plus 6, which is 5x plus 12.
Okay, it was hard for me to follow your numbers there, so let me just show you how I would do it. And this is the way I do every one. And it makes it so you just don't make mistakes. What's the least common denominator?
6.
No. It's the product of your two denominators.
Oh.
Whenever you have variables in the denominators and you're adding them and they're not the same, multiply the variables and that's going to be your common denominator. Okay? Now, what goes there?
1 times, or just x plus 3.
Good. And then I firmly believe in the following, that once you've written that, double check and make sure you have not changed the function. And I can see that I can cross off that x plus 3 with this x plus 3 and I'm left with 1 over x plus 2. So I clearly have not changed the function. And that's another reason I don't multiply these together. Not yet. Because the moment I multiply them together, it's harder for me to say whether I've made a mistake when I converted that function. What's the right side?
X plus 2.
Again, I can cross that off and I got exactly the same thing. So now we have a common denominator and we're going to operate on the numerator. So what is the final answer for just this part of the question?
The final answer for...
Combine the numerator.
2x plus 5.
All over this denominator.
Right.
Now, if I look at all my potential answers, they've multiplied these two numbers together. And it must be x squared plus 5x plus 6. It's a safe assumption to make, okay?
So the answer is A.
Hold on. No. Because look at the problem. It's 1 over that. In other words, my problem is 1 over that quotient. The long fraction bar is under the 1. You see what I'm saying?
No.
It's 1 over that. In other words, we solved for 1 over x plus 2 plus 1 over x plus 3, and that was equal to 2x plus 5 over this. But the question isn't what these two add to. The question is, what is that thing equal to? So we have to flip and multiply. In other words, you have to use the rules of dividing by fractions, which means we're going to flip this denominator and multiply, which means we're going to get answer B.
Okay.
Okay? All right. Remember that number 13? We'll know where to begin next time. These are actually pretty good. I like this test that's online here.
Okay.
Well, I mean, I like it in the sense that I don't feel an overwhelming need to go out and buy the new book and scan it into my computer to get practice questions. These are good ones to have. So as long as you don't do this test in advance, we'll keep doing this test.
Okay.
Okay? So
all right.
I will talk to you next time, Max.
All right. Talk to you next time.
All right. Bye-bye.